Welcome to the Padhai Karlo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Karlo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is the algebraic properties of modulus and principal argument including the powerful triangle inequality. Let's begin. The modulus of a product or two complex numbers equals the product of their individual moduli, mod of z1 z2 equals mod z1 times mod z2, and similarly for a quotient, mod of z1 over z2 equals mod z1 over mod z2. These multiplicative properties genuinely extend directly to any number of factors and specifically to powers. Mod of z to the power n equals mod z to the power n. The modulus of a complex number and its conjugate are genuinely always equal. Mod of z bar equals mod z, and a genuinely useful identity connects a complex number to its own modulus squared. Z times z bar equals mod z squared. This specific identity is genuinely extremely useful for simplifying expressions and for rationalizing complex denominators. The triangle inequality states that mod of z1 plus z2 is always less than or equal to mod z1 plus mod z2. Geometrically, this reflects the genuinely simple fact that one side of a triangle can never exceed the sum of the other two sides with equality, holding specifically when z1 and z2 point in the exact same direction. A genuinely useful related result is the reverse triangle inequality. Mod of z1 minus z2 is always greater than or equal to mod z1 minus mod z2 in absolute value. This specific version is genuinely extremely useful for establishing both upper and lower bounds on expressions in JEE problems. For arguments arg of z1 z2 equals arg z1 plus arg z2 plus or minus a multiple or 2 pi if needed to stay within the principal range, and arg of z1 over z2 equals arg z1 minus arg z2, again adjusted if necessary. A genuinely classic JEE application uses the triangle inequality to find the maximum or minimum possible value of mod z, given some constraint, like z lying on a specific circle, since the maximum of mod of z plus c for a fixed complex number c occurs when z and c point in the exact same direction, giving mod z plus mod c, while the minimum occurs when they point in opposite directions, giving the absolute difference instead. A frequently tested trap involves genuinely remembering that the argument addition property arg z1 plus arg z2 equals arg of z1 z2 holds only up to adding or subtract pi. Simply adding the two individual principal arguments directly can genuinely produce a result outside the principal range -negative pi to positive pi, requiring you to add or subtract 2 pi to correctly bring it back into range. Also remember that mod z is always genuinely a non-negative real number. It can never itself be negative or complex. This seemingly obvious fact is genuinely worth double-checking whenever a computed answer for modulus comes out negative, since that would immediately signal a genuine calculation error somewhere. Let's recap. Modulus is multiplicative. Mod of z1 z2 equals mod z1 times mod z2. And the identity z times z bar equals mod z squared is extremely useful for simplification. The triangle inequality, mod of z1 plus z2 is at most mod z1 plus mod z2, powers finding maximum and minimum values or expressions, while argument addition holds only up to adjusting by 2 pi to stay within the principal range. These properties, especially the triangle inequality, are among the most frequently reused tools across complex number problems. That's the properties of modulus and principal argument. Keep the triangle inequality and the z times z bar identity sharp. They're among the most reused tools across the entire complex numbers chapter. If this video helped, please like it and subscribe to Padhai Karlo for more JEE preparation content just like this. See you in the next one.